Okay, we're going to look at page 99 of your book, and we're going to look at solving quadratic equations now. We're going to start the same way that we solved the absolute value equations, and that is we're going to think about their graphs. So the first function that we want to graph is x squared minus 4. So remember that's a parabola, and it's been shifted down 4 spaces. So that'll be 1, 2, 3, it'll be at 4. Has the same structure as a normal x squared, so left 1, up 1, right 1, up 1. And so we're going to draw our little u here. And so this is our graph, x squared minus 4. And so this has a little bit different question. Instead of having two different functions to graph, it's going to compare us to the x-axis. So the x-axis is this horizontal guy, and we want to look at where they're intersecting. So they're intersecting, it looks like -2 and +2. And so I can check that those are actually on the graph by plugging them in. So if I plug a 2 into this function, 2 squared is 4 minus 4 is 0, which is what this is showing. This is the point 2, 0. And then if I plug a -2 in, squaring that, that's 4 minus 4. That's also 0. So those are our intersection points. So to solve this equation, x squared minus 4 equals 0, we can just say, oh, well, that's happening when x is -2 and 2, and we already checked that. So then let's look at number 2. Again, it's another quadratic equation, but it has a little bit more transformations going on. This time, we're going to shift to the right 3 spaces, then we're going to go down 1. So to the right 3 spaces, down 1 would put us here. Same structure as our regular graph, and so there's our parabola. So again, when does it cross the x-axis? When is it touching on here? Looks like it's happening at, let's see, this will be a 4 and a 2, not 3. So at 4, 0, and also at 2, 0. If I want to check that, let's just plug it back in. So if I plug in a 2, that's 2 minus 3 squared minus 1. That's -1 squared minus 1. 1 minus 1 is 0. If I plug in a 4, 4 minus 3 squared minus 1. That's 1 squared minus 1 minus 1 is 0. Woohoo, it worked. So where does it intersect? When x is 2 or x is 4, which is going to be the solutions to this equation. So what we've just done is solved these two quadratic equations graphically. And so we want to try and have another method that doesn't involve just that graphing. So let's take a look. When we flip over to the next page, we're going to look at solving by factoring. And we've seen this a little bit already, but let's look at it a little bit more. In order to solve by factoring, we want to compare to 0. And the reason we want to compare to 0 is because if you have the product of two things equal to 0, then that means either the first thing, A, is 0, or the second thing, B, is 0. So what I mean, let's look at number 1. If I write this as 3x squared plus 5x, it's minus the 2, we're going to get equal to 0 here. Now we want to factor, so remember we're trying to write this as a product. You could do it a few different ways. Some of you guys do it by guess and check. Some of you guys like to make our little X to organize our information, so then we can use grouping. So remember, we're trying to break apart the middle, and so we need two numbers that will add to the 5, but then the special thing is that they multiply to those ending numbers, which will be a -6. So what does that? Well, we could do 6 and 1 and make the 1 negative. So really that's rewriting this 3x squared plus, we'll have 6x minus 1x in place of that 5x. And then we group. The first two have a 3x in common. We pull that out. We're left with x plus 2. The second two have a -1 in common. We're left with x plus 2. So this will be x plus 2 times 3x minus 1 equal to 0. So what we have then is something times something equal to 0. That means either the x plus 2 is 0 or the 3x minus 1 is 0. So if I minus 2, we get x equals -2. Add 1, we get 3x equals 1. Divide by 3, we get x equals 1/3. So the answers to this quadratic are x equals -2 or x equals 1/3. I'm going to go back to that first question that we had, number 1, part C, and think about that factoring for this problem. So x squared minus 4 is the difference of squares. It'll factor to x plus 2 times x minus 2. So that means either x plus 2 is 0 or x minus 2 is 0. So that would get us x equals negative 2 or x equals 2, which is what we got. So this is using the algebra to help back us up. So we have a few more on here. So you should pause, try and make them equal to 0 first, and then try and factor, and then check back. Okay, so now that you tried that, let's look at number 2. You should have distributed. That would make 25m squared plus 40m equal to negative 16. If we add the 16 over, because again we want it to be equal to 0, we have 25m squared plus 40m plus 16 equals 0. So again, we want to try and factor that guy. So if we look at, well, there's something special you might notice, that that's a perfect square and that's a perfect square. So it'll be like a 5m plus a 4, and actually if we do that, we get another 5m plus 4. If you check, it'll get us that middle. If you want to do it with the x, you can still do that. 25 times 16 is going to be equal to 400. And so again, we needed to add to 40. The only numbers that do that will be 20 and 20. So if I take a step back and do it by grouping, you'll get the same answer, but just so you can see, we have 25m squared. Replace the middle with 20m plus 20m, and then we have plus 16 equal to 0. The first two terms have a 5m. We'll be left with 5m plus 4. The second two have a 4 in common. We'll be left with 5m plus 4 equal to 0. So this will be 5m plus 4 is what they both have, and 5m plus 4 is what we have left over, equal to 0. So now this is going to tell us something times something equals 0. So either the first something is 0 or the second something 0, but that's really the same thing. So we solve this. Minus 4, we get 5m equals negative 4. Divide by 5, we get m equals negative 4/5. All right, let's look at number 3. Now number 3, just to notice, this was actually the function that we graphed on the previous page. So we already know the answer is supposed to come out to be 2 and 4 based off of the graph. So let's see the algebra. So for this one, we need to actually square out the x minus 3. That's x minus 3 times x minus 3 minus 1 equals 0. If we distribute this guy, we're going to get x squared minus 3x plus 9 minus 1 equals 0. That's x squared minus 6x plus 8 equals 0. Now this one, a little bit easier to factor than up above because we have this x squared only here. So if I'm trying to factor this, I know it has to be x and x. Now if I think about things a little bit more, I need numbers that will multiply to an 8 but add to negative 6. Well, that has to be 4 and 2, and we'll make them both negative. And so now we know that either this, well, that times that is 0. So either x minus 4 is 0 or x minus 2 is 0. So for the first one, if we add the 4, we get x equals 4. If we add the 2, we end up that x equals 2. So we have the 4 and 2, which matches what we found graphically on the previous page. So then going to the top, how do you solve by factoring? So give yourself a second to fill out what we just did, which was set equal to 0 and factor. That's the important thing, set it equal to 0. All right, we're going to flip the page and look at something called the square root property. Now the square root property says that if you have some quantity squared equal to a number, that you can actually take the square root of both sides, and then x would be equal to both the positive and the negative square root of a. And so what does that look like? Well, let's go back to number 1 here. X squared equals 9, which we had solved previously. It looked a little different. It was x squared minus 9 equals 0. Now, we're not going to set it equal to 0 this time. What we actually want to have is just whatever quantity is squared needs to be alone. So then we can actually take the square root, which will undo the power. Got to do it for both sides. So then you get x alone, but we need to be really careful here. It's both the positive and the negative square root of 9, which is 3. So we're getting two answers. I wrote it as plus minus, but really the meaning of that is that x is both the positive 3 and the negative 3. Which if you just think about it, you got to square a number and make 9. 3 squared is 9 for sure, you know that. But so is negative 3 if you square it. It's 9. So we need both of those roots. So looking at number 2, again we have the thing that's squared is isolated, so we can take the square root of both sides. So it's going to cancel out the square. So we have x plus 1 equals, again, plus and minus the 3. So it's kind of like saying, okay, what can you square and make 9? Well, you can square a 3, or you can square a negative 3. 3 squared is 9, and negative 3 squared is 9. So that means that that inside chunk, I'm going to write it similar to how we did absolute values. You can say that that inside chunk, x plus 1, has to be a 3, or that inside chunk has to be negative 3, because both 3 and negative 3 squared make 9. So if we solve this, minus 1, we get x is equal to 2. Minus 1, we get x equals negative 4, which both of those will work. You can check by plugging them back in. All right, on number 3, we still have a quantity that is squared, but it's not all alone. We have a 3 there. So let's get rid of that by dividing, because right now it's being multiplied. So we'll reverse that. So then we have the squared thing alone. We'll square root both sides. So we get x minus 1 equals both the plus and the minus. Oh wait, this time we have a negative inside the radical. We have a negative inside. We want to pull that out. And we can't take the square root of 3, so we're just going to have to leave that. So we could write this as x minus 1 equals the positive I square root of 3, and x minus 1 equals the negative square root of 3. Now we still need to solve for x, so I'm going to add 1. These cannot combine because they're not like radicals, so we're going to have 1 plus I radical 3. And same on the other side, add 1, we get x equals, but this will be 1 minus I radical 3. So what some people like to do is just write it all at one time, and so you can see over here, if I add 1, we get x equals 1 plus minus I radical 3. So you can write it either way. All right, got one more, and again, if you notice, number 4 here is exactly the same problem that we just saw over here, which is exactly the same thing that we graphed. We're just looking at it and all these different methods. So looking at it with this way, we want to move the 1 over because we're trying to isolate the thing that is squared. So if I square root now, both sides, that's x minus 3 equals both the plus and the minus square root 1, which is 1. Or again, you could say x minus 3 is either 1 or x minus 3 is negative 1. So when you solve this, add 3, we get the 4 that we would expect. Add 3, we also get the 2 that was expected. So we get the 2 and the 4. If you write it in the first way, you can still add 3, but it looks like x equals 3 plus minus 1. You want to make sure that you simplify that. So that's 3 plus the 1 and 3 minus the 1, which gets you a 4 and a 2 for your x. So we're still getting the same answer, just a different way. All right. For these next few, when you first look at them, they are written more like the first page, and you want to maybe try and factor, but they won't all necessarily factor. So we have this other method called completing the square. And so when we complete the square, what we're going to do is basically turn this into a problem from the last page. Some quantity squared equal to a number, so we can apply the square root property. So we're going to complete the square like we've done before. If you look at the first problem there, we're going to take out just the x squared minus 12x and let it hang out, and then you're going to add something minus something to complete the square. So remember, to make that perfect trinomial square, we take half of whatever the middle is, which will be negative 6, but then we have to square it. So we're going to add 36 minus 36. And again, the reason for doing that is because now these first 3 terms will factor to x minus 6 squared. Negative 36 and negative 3 will be negative 39 equals 0. and we have a problem like the last page. So we want to isolate the thing that's squared, and that's going to mean add 39 to both sides. So we get x minus 6 squared equals positive 39. Then we'll square root both sides, square root both sides. We get x minus 6 equals both the plus and the minus of square root of 39, which that radical will not reduce. It's 13 and 3, but nothing else we could do with that. Then we're going to add the 6 back in. Again, those cannot combine, so we're going to say x equals 6 plus or minus the square root of 39. Final answer. Okay, we're going to skip number 2 for a second and go to number 3. So number 3 looks a little different because this time we have a 2 in the front of our x squared. So if our goal is some quantity squared, we need to pull that 2 out. And it's just of these first 2 terms. So when I pull 2 out, I'm left with x squared minus 6x, and I'm going to again add something, minus something, and plus 3 still hanging out. So the thing I'm going to add comes from taking half of that negative 6, which in this case is negative 3, and we're going to square that, negative 3 squared, which is 9, and then minus 9. So the purpose in adding that 9 was so those will factor, and it'll become x minus 3. Now 2 still gets to come down here, and minus 9 is in a parenthesis. It needs to get kicked out, so it needs to multiply first by the 2. That's why it's in the parenthesis, because of the 2. So that'll be a negative 18. We still have the plus 3 equal to 0. When we add negative 18 plus 3, these two together will become a negative 15. So we have 2 times x minus 3 squared minus 15 equals 0. Again, we want to isolate the thing that's squared. We've just turned this in to the last problem, or last page. So we want to add 15 over, add 15. We get 2 times x minus 3 squared is equal to 15. We can divide by 2, divide by 2. So we have x minus 3 squared equals 15 over 2. We can square root, so we say, okay, that means x minus 3 equals both the plus and the minus of square root of 15 over 2. Let's add the 3 over, so x is equal to 3 plus or minus the square root of 15 over 2. Because we have the radicals going on, we could do a little bit of rationalizing, but I'm just going to leave it like that for now. All right. Looking at number 4, in order to complete the square, well, we don't need to complete the square. This guy's already completed, and so it is actually just like the last page. So we just move the 1 over, x minus 3 squared equals 1, square root, x minus 3 equals plus and the minus 1. And so again, this is just what we did on the last page, just writing it out one more time. That's 3 plus 1 and 3 minus 1. So x is 4 and 2. Now I skipped that second one, and it is doable, but the reason why I skipped it is because we're going to learn one last method that will be much easier to do. And the reason why I skipped it is because if I try and factor a 3 out, then I have to divide by 3. And so we start having a middle term as a fraction. And so there's different methods that work better for different problems, and in particular this one, not such a fun way to do it. So we're going to skip that for now. So then the last method we have is the quadratic formula. The quadratic formula is written as x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'll have a separate video that shows how to, where that formula comes from. For now, we're going to just use that. And really, in order to use it, you need to have your quadratic written in the nice standard form so you can identify your a, your b, and your c. And so when we look at the first problem, it's not written in that form, which means equal to 0 and in descending order. So I'm going to plus the 4x plus the 1 plus the 4x plus the 1. We have 2x squared plus 4x plus 1 equal to 0. And so to use the quadratic formula, we're going to identify our parts, and then it's just plugging into the formula. So a equals 2, b equals 4, c equals 1. So the formula says x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And so the negative b is going to become, you just erase that, we're going to put a 4 in there. And then the b squared is also going to be my little 4. My AC, my A, erase that. My A is going to be 2. And my C is going to be 1. And then on the bottom, my 2A is going to be 2 times the 2. So this will simplify x equals negative 4 plus or minus the square root. Well, we know that that first part is going to be 16, and then this part right here, that's 4 times 2 times 1, that's negative 8. And this is all over, it becomes 4. So we simplify this, it'll be negative 4 plus or minus the square root of 8 over 4. Now this isn't done yet because we can bring out of this radical a 2. So we have a pair of 2's. This becomes negative 4 plus or minus 2 square root of 1, 2 left inside over 4. And then we can reduce this because all of these numbers have a 2 in common. So this will be equal to negative 2 plus or minus square root of 2 over 2. And that would be my final. All right, let's try that again with number 2. We want it to be in that standard form, so we plus 2, we have n squared minus n plus 2 equals 0. We want to identify our numbers in the front. I actually have to put the coefficients. If you don't see it, it's a 1. So our a is 1, b is negative 1, and c is 2. So the quadratic formula says x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And so I'm going to plug in all my stuff. So b is negative 1, and a is 1, and c is 2, and 1. So this is going to be negative negative 1, so 1, plus or minus the square root. If you square negative 1, you get 1, minus 4 times 1 times 2 is 8, all over 2. So that's 1 plus or minus the square root of negative 7 over 2. Now we have a negative inside our square root, so we're going to pull that out as an I. 1 plus or minus I radical 7 over 2. Nothing else can be simplified. All right, and the last one right here, this should look super familiar at this point. I'm going to square this guy back out. That's x squared minus 3x plus 9 minus 1 equals 0. So x squared minus 6x plus 8 equals 0. So we've already done that before. We've seen it on the previous few pages. It's the answer, 2, 4. Answer again, 2, 4. Answer again, 2, 4. So we know what the answer is. We're just showing it in the multiple methods. And so looking at this last one here, we want to use the quadratic formula. So again, we need to identify all the coefficients. We got 1, negative 6, 8. So a is 1, b is negative 6, and c is 8. And the quadratic formula says x equals, the negative boy couldn't decide if he wanted to go to the radical party. He didn't want to be square and lose out on 4 awesome chicks. And the party was all over at 2 a.m. So that's just another way to memorize it. If you Google, you can find out some different ways, but they're good things to know. So I used a song on the last one, and then this one I had that little story. So let's see. If I plug in my a, b, and c to this, I'm going to plug in a b is negative 6. This is negative 6. My a is 1. My c is 8. So this will be negative negative 6. So 6 plus or minus the square root. Negative 6 squared is 36 minus this 4 times 1 times 8 is 32 all over 1. So that's 6 plus or minus the square root of 4 over 1, which is really 6 plus or minus 2 over 1, so just 6 plus or minus 2. Now we should make sure we simplify this. So again, we get x equals, there's 6 plus 2. Oops, I messed up on a part. Let me go back for 1 second. I just noticed I had forgotten to multiply the bottom. So this shouldn't be 1, this should be 2. That should be 2, so actually divide by 2. So 6 plus or minus 2 would be 6 plus 2 over 2, which is 8 over 2, which is 4. And then we also get 6 minus 2 over 2, which is 4 over 2, which is just 2. So we're getting those answers. So x is 4 and 2. Same answer again. And so there are multiple ways that you can solve a quadratic equation. There's just some ways that might be better than others depending on how they are set up.